Hi everyone. Today we're gonna discuss about the amine stress corrosion cracking and alkaline amine type corrosion on the gas processing unit and refinery. As you can see from the process flow diagram on the screen, this is a sweeting system on the refinery. Typical sweeting system and the refinery, all the sour gas uh, gathered and directed to uh, typical aiming uh, system. As you can see, this is the sour gas uh, injected to absorber vessel from the top. Make up water showering, and also we have at the top tray we have a at lean amine, which has a capability of the absorbing the H2S from sour gas and make it sweet gas on the top, and the rich amine, which is has already absorbed the H2S from sour gas. This goes to process exchanger and it goes to the regenerator to remove the H2S and CO2 from the rich amine, and again by reboiler and heating all that H2S and CO2 removed from the rich amine and make it lean amine, and lean amine compact again. This is a closed circle of this system, and regenerate the lean amine again by removing the H2S and CO2. And finally, H2S and CO2 goes to acid gas service, okay, to extraction of the H2S and CO2 and safely remove those toxic gas from the service. And this is a bottom process flow diagram shows the atmospheric distillation unit in the refinery and sour gas header. All the sour gases gathering from all the plants and heading to amine treating. Okay, and this is on top of the atmospheric distillation unit. Goes to gas processing. All the gas from different units, from hydrotreater, from isomerization plant, and heading to gas processing, and one of the gas treating to remove the H2S is a Metrox treater, and fuel gas goes to amine treating, and after removing the H2S and CO2 and all the toxic of the from gas and fuel gas, and feed to refinery fuel and use it in the refinery. And H2S, removed H2S goes to Claus sulfur plant to create and generate the sulfur. And this is the sulfur is a side product of the refinery. Normally that amine stress corrosion cracking happened on the carbon steel. Also is a cracking probability increase with temperature and stress levels. One of the best method, and to avoid of the temperature range between 40 C and 150 C, and all this damage cracking report that temperature lower than 40 C and higher than 150 C. Between this range, between 40 and 150 C, this is that this amine stress corrosion cracking is low, and we can do the water washes that to carry over, cracking normal intergranular type, not transgranular type of the crack. Most of the equipment of the amine service also exposed to wet H2S cracking damage. Mitigation and inspection we can do and detect this type of the upgrading material and monitoring of the integrity operating window IOW by avoid of this threshold temperature range, One of the best mitigation to conduct and implement the post-well heat treated on the welding on the for carbon steel material to reduce the stress remained on the weld lines. The number of damaging alien systems reported higher than other systems such as DEA, so the methyl ethyl amine system is more suspected to its damage. Before commencing standard post-well heating and non-post-well heat treated vessel and ensure that uh, alkaline residual and alkaline fine service is properly washed out and removed of the material. And in this case, we need to make sure this vessel properly flushed. And authorized engineers should verify and validate the welding procedure for repair of the welding and confirm the post-well heat procedure, temperature of the post-well heat treatment, retention time in the post-well heat treatment is very, very important. Heating and cooling rate of the post-well heat treated procedure very important. And the best inspection to make sure we have no any stress corrosion cracking is the PAUT, phase A, UPT or FE, and advanced with high sensitivity SWUT, shear wave UT. The best internal inspection could be empty magnetic test or red fluorescent magnetic test or WFMT. Some people stand for red fluorescent magnetic test. Alkaline and amine type corrosion, we have it. This is another type of the damage is could be happening on amine system, but this is not a cracking type. This is going to be corrosion. Amine corrosion generally and localized corrosion this is not a general corrosion, and that occurs the amine treating process and is affect on the carbon steel corrosion is caused by dissolved acid gases like CO2 and H2S. CO2 and H2S in the certain temperature penetrating on the carbon steel, amine the degradation products, heat stable amine salts, and other contaminants. And amine solution generally not corrosive because they have either low conductivity or high corrosion rate with increasing temperature, particularly in the rich amine surface. If the pressure drop in the large amount, the temperature above 105 C can cause acid gas flashing and severe localized corrosion due to two-phase flow. Process steam streams velocities which influence the amine corrosion rate and nature of the attack. Corrosion generally uniform, however, high velocity and turbulence will cause the localized metal loss. The fresh amine are not corrosive, but always those used and regenerated amine is more suspected to corrosion, amine corrosion. When they are located with acid gas, they become the less basic and consequence more corrosive. The acid gas dissolved in amine solution will cause general and localized pitting corrosion of the carbon steel. The corrosion accelerated by increasing the acid gas loading limits. The normal limits for methyl ethyl amine are 0.45 mole per mole, where combination with H2S and CO2 and present 0.7 mole to mole for on the H2S system. The acid gas loading is equal to CO2 plus H2S and total HSS, they call it heat stable salt. The higher loading level, the corrosivity of the amine increase and acid gas breakout may be happen increase of the turbulence of the flashing. Some amine have minimum recommended lean loading to preserve the steel's protective sulfide scale, especially in the liquid and vapor interface in the regenerator and reboiler, as already discussed in the process flow diagram. The corrosion of carbon steel increases with temperature in constant acid gas loading. Temperature limits vary from the plant to plant, but generally should not be higher than 125 C for carbon steel material. So this temperature threshold is very important to avoid of the amine corrosion. Process velocity and turbulence is very important. The high velocity of the amine turbulence in flow removes the protective scale from the H2S and the carbon steel. So we need to avoid of the turbulence of the fluidity pattern. And normally there is a number as a 6 meter per second for velocity in the amine system. And amine service which operating with more than 93 C in the not supposed to be more than 2 meter per second velocity. The pressure decreasing cause of the acid gas breakout flashing raises the corrosion rate. We should avoid of the pressure dropping, okay, and design the piping system to minimize the pressure drop during the process and service. Heat stable salts, HSS content is key factor in total amine stress in the amine corrosion. Heat stable salts content and percentage reduce active amine MEE from the target of the 20%. Amines can be thermally reclaimed and recovered easily. However, in the case of the both DEE and MDEA, degradation products hard to easily reclaim and other forms of the reclamation must be used such as vacuum distillation, ion exchange analysis and other chemical methods. Corrosion potential of the high level of the HSS could be managed by adequate filtration and excluding the oxygen from the system. So oxygen must be removed and filtrated from the system. This is recommended that the HSS high stable salts content be limited to maximum 10% of the active amine strength and MDEA. For example, for DEA, that limitation for HSS is 25% strength and maximum H2S content must be less than 2.5%. However, the MDA 10% when active amine concentration strength drops to 1% and 5% for MDS. So as you can see, MEA more sensitive for amine corrosion. The corrosion of the unit with MEA is more severe than DEA, and since the MEA is more prone to degradation, also MEA and DGA are most corrosive because they need higher temperature for regeneration. Okay. We can regenerate the MEA far below temperature in compare with MEA and DGA. MDEA could be easily stripped with less corrosivity. Also, MDEA cannot be thermally reclaimed, which may build up a higher level of the HSS. Mitigation, inspection, construction material upgrading could be very helpful to minimize the amine corrosion. Monitoring of the service corrosivity by corrosion probes and coupons installing on the fixed equipment and a certain location on the process piping could help and monitor the corrosion rates and corrosion patterns on the fixed equipment and specifically in the Amine service, in the, for example, absorber vessel or regenerator vessel, we can install the corrosion probes. And time by time, that must be that control the level of the heat stable salts level. We can monitor the level of the HSS by sampling, and another mitigation could be reducing the high velocity area by changing the design. Process piping design is very important to minimize the turbulency and minimize the service velocity. The reason for minimize the service velocity to avoid of the removing the protected scales from the service. And the damage detection methods could be VT, visual test or visual inspection, graded wave UT, GWUT, and RT radiography test on the hotline Amine service, and weld zone, specifically weld zone with red lines very suspected to high stress location of the. And also we can do the test by thermography test and infrared camera. I hope this presentation helped you in your job and your research, and have a great day. Thank you.